Good afternoon once again. So we will now solve an example for a Venturi meter. We will first solve an example for a horizontal Venturi meter. So in this case, a typical problem, we need to solve for the Q, which means we need to solve for the discharge. If given the following, we have the diameter at point 1, which is 25 millimeters, diameter at point 2, 19 millimeters. We have the delta H, or the difference in height of our liquid inside our differential manometer. The delta H is equal to 3 centimeters. And now we have C. C is actually the constant C. C is a constant. uh, that's actually the head loss or the friction coefficient. This will this 73 is the it uh, considers the head loss factor of the device. So we have this Venturi meter. It has since, di ba, in our previous discussion, we have if we have sudden contraction, so we have head loss. So C considers all the losses that is occurring inside our instrument, our manometer. So this is actually our manometer, our instrument. So C is the coefficient factor. Actually, it will be C will be multiplied uh, will be multiplied to the actual or the theoretical Q, so that we can solve for the actual Q. By the way, those equation that we derived earlier in my previous videos, those are theoretical velocities. So wala pa man nato gi-consider ang kuan. Based on those derivation, we didn't consider the friction losses. So we considered those equations as theoretical velocity. When we multiplied it to each area, so the Q is just a theoretical discharge. So we multiply it by C to determine the supposedly the actual discharge. Okay, so based on the given, we have 25 bigger diameter, smaller diameter 19 mm, difference in H 3 cm, and C, which is 0.73. So if we can recall, sara to ang atong equation. So we need to solve for the, I will just use this black. Yeah, theoretical velocity is sa ganito, P1 minus P2 over gamma times 2G n squared minus 1. So in this equation, the only unknown is P1 minus P2. For n, by the way, we can solve for n. N is, tama to siya, that's d1 square over d2 square. That is 25 square over 19 square. Pila man na siya. How much? Ito ang calculator. Dara akong calcio. So 25 over 19 squared. That's 1.73. Rn is equal to 1.73. Sakto. Yeah. Basin malipat mo ha. N is d squared over d1 squared over d2 squared. Then this inikabot sa equation when we plug in it to the equation, ato pa dun na siyang i-square again here. Right. So the only unknown is P1 minus P2. So again, we will go back to our drawing. So we need to determine P1 minus P2. So we have delta H. Okay, so we will establish first our point 1. So this is our point 1. So we have here the blue. We have here the pressure at point 1. Then we have here pressure at point 2, right? So please follow with me. So point 1, we will start at point 1. Ato ni siyang i-assume this height here. Ato lang ni siyang i-assume nga kini siyang height. We'll just assume it as y. Ang nakabaloan na, we don't know that height, so we'll just put it as y. So pressure at point 1, then from here going downward, paubos, going downward, or ari lang sa takotob at this level. So this distance is y. So pressure at point 1 plus gamma of water man, di ba? So water, gamma of water times y, di ba? Going downward man ta. Then from here going downward further plus it's still water man nga rin, water man tanan. So gamma of water times the distance is delta H. Okay, and then from here, since they are equal, they are level, from here going upward, that's gamma of, or I don't know what is that liquid, but its specific gravity is 1.5. So since saka man siya, so it's minus, di ba? It's negative. So SG 1.5 times 9.81, that's the unit weight of the liquid, times distance niya delta H. Okay, and then going upward further, bata na to sa ubos, continue going upward further, minus gihapon. So gamma, since water naman ni siya, so gamma of water times y, that would be equal to P2. Right, so we can rearrange this equation gamit ko black. Atal lang sang i-plaster ha para sa iyo nara pag-follow. P1 plus gamma of water times y plus gamma of water times delta H minus 1.5 times 9.81. This is actually this 1.5 is the specific gravity of the liquid. It's 9.81. 9.81 is the unit weight of water. Yeah, 9.81. Unit weight of water times specific gravity. That's the unit weight of the liquid. Times delta H minus gamma of water times y P2. So in this equation, we can cancel out gamma of water. Plus man siya, di ba? This one is minus. So we can cancel out the two. Cancel out naman siya with each other. So what remains in the equation is this one, delta H, gamma of water. Actually, this one, kini siyang Y. Actually, this is actually, we can write it as gamma of water. Diba? That's 9.81. So, rearranging this equation, P1 minus P2, balhin sila sa right. So, that's 1.5 1.5 gamma of water delta H minus gamma of water delta H. Okay, do you follow? So furthermore, we can simplify the equation as sama ni gamma of water delta H 1.5 minus 1. So P1 di ay minus P2 is gamma of water, di ba? That's tanganan na unit 9.81 kilonewton per cubic meter. That's the unit weight of water times delta H, which is ano ganito yung delta H na to? 3 cm. 3 cm. Atong express in terms of meter, that's 0.03 of a meter. 3 cm. And times 1.5 minus 1. So we can solve P1 minus P2 as pila man kahanin 0.5 times 0.03 times 9.81 since that's kilopascal, ito na i-convert into Pascal, that's 147.15. 0.15, that's Newton. Ato na nang multiply by 1,000 per square meter. Alright? So, nanatay value sa atong P1 and P2. So, going back to our equation. Okay, so solving for V1, P1 minus P2, that's 147.15 Newton per square meter over gamma, unit weight of water, which is 9 point, ato lang yung kuandaan para makancel, 9,810 Newton per cubic meter times 2G times 2 times 81 meters per second squared over N. Pila tayo balis ng N? N is 1.73 square minus 1. Then need to square root the entire thing. So solving for V1, pila kaya ni? First, before solving, we will examine first the unit. So the units is cancel ang Newton, Newton, Newton. Then makancel ni siya. Then meter na lang ang nabilin. So ang unit ani niya actually it's atara ni sumpay diri. Unit ani is actually meter squared per second squared. But since ato man siyang square root, we're going to square root this one, so that's meters per second, which is the unit of velocity. So solving for the velocity based on this equation, gamit yung calculate 147.15 then times 2 times 9.81 over 1.73 square minus 1. The value of velocity is 0.384. 0.384 meters per second. If you follow the video, then if naamoy makita nga sayop, if you can find some errors or maybe nasayo pag compute, so kindly comment in the reply option aning a post. So based on our computation, we have 0.384 as a value of our velocity. 0.1 B akong i-review 147.15 9, 8, 10 2 times 9.81 170 minus 1 square. Okay, 0.384. So we now have the velocity. We can now solve for the Q1, which is actually equal to Q2 or simply as Q is equal to 0.384 meters per second multiplied by the area. Pila may area, that's pi. Pila may diameter at 0.1, that's 25 millimeters. Yeah, that's equal to 0.025 of a meter over 4. So Q is equal to 0.384 times pi times 0.025 squared divided by 4. That's 1.88 times 10 to the, what is this, negative 4, or roughly pila man patakan natin yun, sorry, cubic meters per second. That's roughly, multiply na tag 1,000, that's roughly 0.188 0.1885 liters per second. So that's the Q. This is actually the theoretical Q. It's actually the theoretical Q. So if we're going to solve for the actual Q, the theoretical Q minus multiplied by the C constant 0.73, right? So 0.1885 times 0.70, how much? 73. By the way, ang C coefficient is wala na siya unit. So, it's unitless. So, the actual Q is actually 0.1376. Okay? So, we'll review our sample. So, we are given a horizontal manometer with a throat diameter of, or with a mouth diameter of 25, with a throat diameter of 19 mm. We have the difference in elevation of our liquid in the manometer, which is yung delta H is 3 cm. We have the specific gravity of the liquid in the manometer as 1.5. So first, we solve for our n, d1 minus d2 square, so 1.73. Then we solve for the difference in pressure, P1 minus P2. Then we found out the difference in pressure is 147.15. And then we substitute P1 minus P2 to our equation. So we solve theoretical velocity as 0.384, and then we solve for the theoretical discharge as 0.1885 liters per second. That's the theoretical discharge. And then we multiply it by 0.73 C. So we solve for the actual Q as 0.1376 liters per second. Okay, so that would be all for this example. So I think we'll have one more example for this Venturi meter flow measuring device. So good afternoon. Thank you for your time and attention.